Okay, so sharing my screen now. Okay, can you see my screen?
Yes, ma'am.
Okay, all right, good. So I was explaining box plot last week, and just look at my cursor. So I said this part is Q3, which is 75th quartile, right? And I said this part is 25th quartile, that is 25%. 25th quartile, this part is 75th quartile, 75th, yes, quartile. This part is 25th quartile. Oh, let me not put it like that. Sorry, I'm mixing it up. So let me do it like this. This is Q2 quartile 2. This is Q4 quartile 4. So Q2 middle is Q3. Upper part of this box is Q4, right? So Q2 is 25th percentile. Q3 is 50th percentile, which is the median. Q4 is 75th percentile. So this, and I said this is the lowest value, and this is the highest value. So as you can see, Q2, which is 25th percentile, is in between the median and the lowest value. Q4, which is 75th percentile, is in between the median and the highest value. Now, I want to explain how they came about all of this Q3, Q4, median in a data set. So how do you come about that in a range of data sets? What does it mean? How do you come about that? So this short video is going to explain all of that to you. And this short video is also going to explain what outliers mean. So I'm going to play the video now. And but before that, I need to be sure that you'll be able to hear my audio, because I had problem with it one time. So let me see. Does anybody know how to include audio?
I think Mana said you might have to reshare your screen again. When
Okay, I should reshare my screen. Okay.
Yeah.
Okay.
Yes,
Okay.
ma'am. Then add audio.
So
Then click on
I'm
add
sharing my
audio.
screen. So where should I click on add audio? I've reshared my
No,
screen.
you will click on. You will see the add
So,
audio, the dialog box that comes up when you click share your screen.
Okay. Let me do it again. Emmanuel explained to me, but I've forgotten again. So let me stop sharing. Then, so I should click on share, right?
Yes, ma'am.
Then include system audio. Okay, I've seen it. So I should tick it.
Yes.
Yeah.
Yes.
Okay.
Yes, ma'am.
Then share screen. Okay, I think I've done that now. Somebody's waiting. Let me just get this person in. Okay, so I believe you can see my screen again. So let me play the video now. Let me know if you can hear.
lesson, we're going to talk about
Can you
how
hear?
to find the interquartile range.
Yes, you can hear.
Yes,
I can hear.
Okay.
Yes.
Okay, so let me start it again. All right. So this is going to play for 12 minutes, and I think it's worth it. So listen carefully. If you don't listen, you will not understand. So, and it's like the simplest. I saw the video and I was like, okay, this is perfect for explaining. So please pay attention. Don't do anything else, even if it at least for these 12 minutes. Just try to listen so you'll be able to understand the concept of quartiles and outliers once and for all. If you can get this video, you wouldn't have problems with quartiles and outliers and what they mean and how they're represented on a box plot. So let me mute myself because I want to quickly do something else in the next 5 minutes.
In this lesson, we're going to talk about how to find the interquartile range, as well as the presence of any outliers. But let's take some notes first. So let's
I want to confirm that you can hear the video. Can you hear the video?
Yes, we can.
Yes.
Yes, we can.
All right, I'm going back now.
Say we have a number line. On the left side, this is going to be the minimum value, and on the right side, the maximum value of the data. So let's say we have a number line. On the left side, this is going to be the minimum value, and on the right side, the maximum value of the data. Now the median of the data is the second quartile. This is basically the 50th percentile. The minimum will be at the 0th percentile, and the maximum is basically the 100th percentile. Now, Q1 is going to be the median of the lower half of the data. And Q3 is the median of the upper half of the data. And so that's how you could find the three quartiles. The interquartile range represents the middle 50% of the data. IQR is the difference between the third quartile and the first quartile. And so that's how you find it. By the way, Q1 represents the 25th percentile, and Q3 represents the 75th percentile. Now let's talk about the outliers. Sometimes you may have a data point that is either all the way to the right, that's very high, or to the left, that is very, very low. Now, here's what you need to do in order to find if a number is an outlier. The outliers will exist outside of this range. It's going to be outside of Q1 minus 1.5 times the IQR value to Q3 plus 1.5 times the IQR value. So if you have a number that's in the list and it's not in this range, it's outside of it, then that number is considered to be an outlier. And we're going to do some examples so that you can see how this process works, like how we can go about determining if a number is an outlier or not. So let's say if we have the numbers 5, 8, 15, 26, 10, 18, 3, 12, 6, 14, and 11. So let's go ahead and find the IQR value, and let's see if there's any outliers in this list. So what's our first step? What's the first thing that we need to do here? The first thing you want to do is you want to rewrite this and arrange the numbers in ascending order. So 3 is the lowest number. Next, we have 5, and then 6, and then after that is 8, 10, 11, and then it's 12, 14, 15, 18, and then 26. Now, the next thing you want to do is identify the median of the entire data set. So the median is basically the middle number. If we eliminate the first two numbers on both sides and then follow that process until we get one number in the middle. So this is the median. So 11 is the second quartile. So what I'm going to do is I'm going to draw a line here, and I'm going to put 11 below that line. So this is Q2. Our next step is to identify the median of the lower half of the data. So the middle number of these 5 numbers is 6. So let's put a line. And so 6 is going to be Q1, the first quartile. Now let's do the same thing on the right side. Let's identify the median in this area. So the middle number is 15. So 15 is the third quartile. When you think of the word quartile, I think of quarters. 4 quarters equal $1. And so the quartiles, they divide the data into 4 equal parts, as you can see here. Now at this point, we can calculate the IQR, the interquartile range. It's the difference between the third quartile and the first quartile. And so we can see that the third quartile is 15 and the first quartile is 6. So 15 minus 6 gives us 9. And that's how you can calculate the interquartile range. Now our next step is to determine if we have any outliers. So looking at the numbers in this list, do any one of these numbers stand out? Is there a number that appears not to belong to the rest of the pack? Now to me, 26 seems to be a little far out from all the other numbers. So is 26 an outlier? Let's find out. So what we're going to do is we're going to plug our data into this interval, Q1 minus 1.5 times IQR, and then Q3 plus 1.5 times the IQR value. So Q1 is 6, and the interquartile range is 9. Q3 is 15, and then it's going to be plus 1.5 times 9. 1.5 times 9, that's 13.5. So 6 minus 13.5 is negative 7.5. And then 15 plus 1.5 times 9, that's going to give us 28.5. Now an outlier will be any number in this list of numbers that is not in this range or that is outside of that range. So is 26 outside of this range? 26 is in this range. So therefore, 26 is not an outlier. Now, let's say if this was 29, then it would be an outlier. Let's try another example. So let's say we have the numbers 11, 31, 21, 19, 8, 54, 35, 26, 23, 13, 29, and 17. Go ahead and pause the video and try this example for yourself. Calculate the interquartile range and determine if we have any outliers in our dataset. So let's begin by writing the numbers in increasing order. So we have 8, 11, and 13. So after 13, we have 17, 19, and 21. And then after that, we have 23, 26, and 29. And then the last 3 numbers are 31, 35, and 54. So we have a total of 12 numbers. Our first step is to calculate Q2, the second quartile, thus splitting the data into 2 equal parts. So if we eliminate the first 2 numbers on both sides and then follow the pattern, notice that we have 2 numbers in the middle. So to calculate the second quartile, we need to take an average of those 2 numbers. So we can add them up and then divide by 2. 21 plus 23 is 44. 44 divided by 2 is 22. So this is the second quartile. Now we have 6 numbers on the left and 6 numbers on the right. So now we need to find the first quartile. So what is the median of these 6 numbers? If we eliminate these 2 and then those 2, we have 2 numbers in the middle. So we need to average those 2 numbers. That was weird. So we're going to split the lower half of the data into two equal parts, where we have 3 numbers on the left, 3 numbers on the right. So the average of 13 and 17 is going to be the middle number between those two, which is 15. So 15 is the first quartile. Now to find Q3, we need to split the upper half of the data into two equal parts. In this case, 2 parts of 3s. So the average of 29 and 31 is 30. So 30 is going to be the third quartile, our Q3 value. Now once you have Q1 and Q3, you can now calculate the interquartile range. So it's going to be 30 minus 15, which is 15. And so this is our IQR value. Now let's focus on any outliers. 54 seems to be a very high number. Could this be a potential outlier? Let's find out. So first, let's write this expression. Q1 minus 1.5 times the IQR value, and then Q3 plus 1.5 times the IQR value. So Q1 is 15, and the IQR value is also 15. Q3 is 30. One point five times 15 is 22.5. And so if you take 15 and subtract it by 22.5, that will give you negative 7.5. Now 30 plus 22.5, that will give you 52.5. Now notice that 54 is outside of this range. Because it's outside of this range, 54 is an outlier. So I'm going to put a check next to it. And so now you know how to determine if a data point represents an outlier in the data set. And you also know how to calculate the interquartile range. So that's it for this video. Thanks for watching.
Who is clapping?
This is Octave.
Who is that? Let me see. Sunday. Oh, Sunday, you're the one clapping. You almost
Yes, ma'am.
beat me up last week. Oh, sure you know. You remember?
No,
Eh?
I can't.
You can't. Eh. So what do you think?
Yeah.
What if you liked the video, let me see your hand. And if you understood what was
Like,
explained in the video. Okay. Anybody else? Cool. Other people are not saying anything. Okay, just talk. Just talk. I did. I understood. Let me just hear.
Oh, we all
I did.
I
Okay.
understood the video.
Okay, cool. So I think okay, cool. Thank you, everyone. So I think I made a mistake with the Q1 and Q3. The things I usually like mix them up. So it's clear now. We know that Q2 is median, right? And so Q2 is median. Q1 is the 25th percentile. Q3 is the 75th percentile. And then you already know how to get outliers, plus or minus 1.5. So that's about outliers. So for those of us asking what are outliers are, statistically, you've seen what outliers are. This is the range for outliers. So Q1 minus 1.5, so 1.5 to the back of Q1, 1.5 to the front of Q3. Okay, so it's good we understand that now. So that is the way outliers are gotten for box plots. And so here, so this is the way these outliers are gotten. So you might see the values, some of them might look very close to the maximum value, but they are actually outliers from the calculation that were shown in that particular video. So yep, so that's about outliers and interquartile ranges. So very quickly, let's move to, I would like us to, maybe we should just even create a box plot now so that we'll just understand what I explained. So we'll understand it immediately. So let me, okay. So let me go to my workstation. So today we're going to be doing box plots. We've done, okay, we did arrows and polygons last week, but then I'm going to show us how to create a polygon with locator, something called locator. You can use locations to create your polygon. And I could also specify the values if you have the values you want to use to create your polygon. So I'll be explaining that. And I'll also be explaining how to plot multiple variables using the pairs function, the coplot function, and one other function. There are three of them. So I'm not going to be doing much of the slides. I'll be using the workstation majorly for today's class. This is taking too long. Why is it like this? I was going to cover my entire screen. So today is 10th of August. Okay, so I'll just create a box plot, and then we're going to be getting the data from our datasets folder. So let's quickly see that the data is present there. It's in home/Hadoop and datasets. So once you use it's I'm on page 170 of your lab workbook. I'm on page 170 of your lab workbook. So once you use COMP-EXP data, COMP-EXP data. So here it is. This is it. So it's present here. So let's load the data in. So let's navigate to home/Hadoop.
I'm sorry, you said what page?
170.
All right, thank you.
So we want to get this data, and we're going to name it CEXP data on page 170 of your textbook. So read.table, we're reading a text file, so we have to use the read.table function. Data sets /compexp.txt. Mind your casing, it's case sensitive. Then we want it to bring in the header too. So header equals true. So we're reading in this data. Let's see the first, or let's see what it looks like. Let's use this. So this is what it looks like. We have the EXP columns, and we have the output. So these are categorical variables, as you can see. We have N25, N50, and some other ones. So let's create a box plot for this. So we'll plot, like I said, for categorical variables, R automatically creates a box plot for you. Then if you now want to create a bar plot, you specify it. So when it's a categorical variable, because box plots are more explanatory, as you've seen, R automatically creates a box plot for you. So let's plot it. Let's plot EXP data. Let's plot EXP from EXP data. Then plot it by outputs. And then we want to give it a label. So let's label it. What did they label it as? Let me just follow up here. They labeled it EXP. So EXP. And let's label the y-axis output. So here. So see, it plotted this box plot for us, this box plot visual. And then you can see that we have categorical variables. We have just 5 of them. Then we can see that the median for this one, which is Q2, is way lower than the median for this. And we can see that this has a wide spread. So box plot shows how widespread the data is. So we can see the range of N to 5. We can see that it ranges from about 450 to about 700 and something, probably 750. So that's the range of spread of N to 5. And then we can also see that we can see the median. We can see that the above the median value, we have a larger range of values above the median value. And we can also see that between Q3 and the maximum value, we have more values for this compared to the rest of them. So you can see a lot of things from your box plot data. So from your box plot visual. So that's about box plot, and I'm sure we understand box plots already from the explanation. And here we can see we don't have any outliers. So all the data points are within 1.5 minus Q1, right? Yes, 1.5 of interquartile range from Q1 and 1.5 times interquartile range plus Q3. You can see that the data points are within that range. So we don't have any outliers for each of the box plots. So that's about box plotting. Okay, are there any questions? Let me know, assume that there are no questions. I don't know why.
Sorry, ma. If we had higher, how would you have known, ma?
Okay. That was exactly what I wanted to ask.
If you have what? If you have what?
If we had outliers, ma.
I think you're on mute, ma'am.
Yes, ma'am.
Sorry. So these are the outliers. the outlier for this particular value 4 is this, and below the Q1 is this. So these are the outliers, the ones represented with the circle dots or the circles here. So can you see them? Do you understand now? Is anyone there? Can you hear me? Do you understand?
Yes, ma'am. Yes, ma'am.
Yes,
ma'am.
Okay. So for the ones below Q1, you have them here, and for the ones above, you have them here. So below, I mean outside the range below, they are here, and for the ones outside the range above, they are here. Just like the video we watched, that 59 or 54 or so would have been on top because it is above the range. So if we had something below the range, maybe like 2 from the video we watched, it would be somewhere here below. So this is for this particular point 4 and so on. So that's about outliers. So for that one, we do not have any outliers for any of the box plots. I would have really loved it if we had an outlier so you see it, but then we don't have any outliers for this one. So that's about box plots. Let me quickly show us how to create polygons. So polygons specifying where you specify the location you want. So first of all, I want to create an empty box where I would have my polygon inside. So let me just do a box of range 1 to 10 for the x-axis, a box of range 1 to 10 for the y-axis. I don't want any x labels. I don't want any y labels. So let's see what this gives. Okay, so you can see it's plotted x when x is 0, y is 0, when x is 1, y is 1, and so on. 1, 1, 2, 2, because we have 0 to 10, 0 to 10. So it's plotted each of the points against one another. But I don't want this plot. I just want the box. So I'm going to look for how to remove this plot and how to remove these values. And I remember I taught you how to remove values. You use axt to remove values. So the values on the axis, on x-axis, to remove them, use this equals to n. And then to remove the values on the y-axis, use this equal to n too. So that removes the values, right? But then I still don't want this plot. So I'm going to do type equal to n. And I remember I told you about type. So before that, let me quickly even show you something. So let me try something out. So see what I did. PCH equals to 15, and it changed the shapes I used to plot my data. Now I want to explain what PCH is. So PCH, wait, did I talk about PCH last week?
Yes, you did.
Oh, I did. Okay, cool. So PCH helps you change the shape of your data. So if I wanted to change it to like a triangle, it will do that. So you can check your manual. There's a code to show you all the PCH values, and the shapes that represent them. So you can check the code in your manual and run the code on R. So you'll be able to get the shapes you would like to be using and know their PCH. So that's about PCH. So now I don't want anything. I don't want anything on my chart. So I'm going to do type equal to n. And if I wanted to do, I remember I talked about this. It will put a line for me. Type equal to L. That's line. So I don't want anything. So it's going to give me an empty plot. So now I have this empty plot, and I want to plot a polygon in my empty plot. But I want to be able to specify my location. I want to tell my chart that, okay, these points that I'm selecting are the places I want you to plot my polygon on. Now, please watch carefully so that you understand. So I'm going to put it into a locations object name, and there's something called locator. The locator function helps you to specify locations on your plot workspace. So I want to plot a polygon with 6 sides. So I want a locator with 6 points. So I'm going to put locator into brackets 6, which is going to help me with specifying the 6 points I want for my polygon. Now, after putting locations, assigning locator to object locations, I'm going to run this. Now, see what happens. When I ran this, if you come into your console, you would see that there is nothing coming up here. It is showing you that, okay, you still have something you have not done. So what have I not done? I've not specified my location. So I'm going to come to my plots, and coming to your plot, there's going to be a cross sign. So you can see the cross sign here. I ran this code. It didn't run anything here. It's telling me, okay, you've run the code, but sister, you've not put your locations. So now it's going to give me this plus sign to be able to include my locations. So I'm going to select, click, and select this place. 1, I've selected that. It's going to show a blue round sign. 2, that's second location. 3, it's still not going to show anything in the console because I've only selected 3 locations until I select 6. 4, that's fourth location. 5, that's fifth location. 6, that's sixth location. Now you see, I've selected 6 locations, so it has shown me this sign that, okay, you can go ahead now to run your code. So I've selected my 6 locations. So let me show you the coordinates of the locations I selected. Locations. So see, it gave me coordinates of x and y axis. So the location, the first location I selected was at a coordinate of 2 point this, comma 8 point this. The second location I selected, you know, each location on your graph has a coordinate of x, comma y. So don't tell me how I came about x, comma y, because I'm explaining now. So, so let me just continue. You're free to ask questions, don't mind me. But then, when you select a point on an x, comma y axis, an x, comma y chart, it gives you a coordinate x, comma y. So the first point I selected was at the location 2.88 blah blah blah, comma 8.88 blah blah blah. That was the first location I selected. The second location I selected was at 7 points this, comma 9 points this. The third location I selected was at this, comma this. The fourth location I selected was at this, comma this. So this is a good way to get a vector of points on your chart. But then this is majorly useful for creating shapes. So you want to create a shape and you want to be able to specify the location yourself. You can use this, and it even gives you the coordinates of the locations that you selected. Now, I want to plot those locations I selected. So I'm going to do plot polygon. I want to plot as a polygon. So polygon of locations. So here. So see. So you remember it came like this, I came like this, I came like this, I selected this, this, this. So it has joined those locations I selected to one another. And let me explain how I came about x and y again. These points that I first selected will definitely have an x value and a y value, which is shown here and here. The second point I selected has an x value and a y value, which is shown here and here, and so on. Any questions before I continue? Any questions? Okay, if you don't have questions, tell me you understand.
Ma'am, just something else. So, let's say we don't want to draw a polygon to like want it to be very specific. Like we don't want to assume points on our plots. Like saying we have our plot, say 1, 2, 2, 3. Is there any command we can write on the source code so we could just assign our coordinates to these locators instead of us coming to touch points? Because I don't know if we do that, we may just make some slight error adjustments. I don't know.
So you want to choose point you want. So you can choose the point you want. Let me not have to rack my brain around it. So I did something because I was expecting this question actually. So I did something and I specified some locations. So those locations I specified, I had to like understand how I wanted my polygon to look, and then I specified those locations. So let me quickly go into what I did. Let me check for what I did, because I was actually expecting that question. Okay, so let me copy this. So okay, before that, okay, let me just put this here. But before this, you can also add a color. So let me color it red. and it's colored red. So that's about that. But then I don't want to assume locations, okay? I want specific locations on my chart. I want specific locations. I want this thing to be on my chart. So I can choose this. I can say axis equal. I'm going to create a list. So you know that locations is a list, right? Hope you all know that locations is a list. When you have this, a list consists of more than one vector. So you see it's a list. So a list consists of more than one vector. Locations has vector x and y. So I want to create a list. I don't want to specify the locations myself. So these are my new locations, list x, y. So let me see axis. So, oh, I didn't run this. So I have this, this for the first point, 5, 2 for the second point, 6, 5 for the third point, and so on. So now I want to plot this polygon of axis. So this is it. Oh, so let me, you know what? Let me clear this and do this again so that you see it well. And then, okay. So here, so this is a polygon with 6 sides that I specified. So if you know the points you want your polygon to appear on, if you know their coordinates, you can specify them. So you just put, for the first point, what is the coordinate? You put it here, x, y. What's the second point? This, you put it here. So if I wanted to do a triangle is also a polygon, but a polygon with 3 sides. I can say, so let me quickly do something with you. So x equal to, and y equal to something. So let me see, I want to plot triangle somewhere around here. So let me include my x labels and y labels so that I'll see what I'm plotting. Let me include my x labels and y labels. So when you know your coordinates, you can easily plot what you want when you have your coordinates. So let me do this. Oh, not the labels now. This is what I wanted to remove. So I wanted to remove so I want I don't want the labels there, but I want the values. So here. So let me quickly plot a triangle. So I want the triangle, I want the first part of the triangle to be on 6, 6, which is this point. So I'm going to put 6 here, and I'm going to put 6 here. So 6, 6, right? That's the first part of the triangle. Now, the second part of the triangle, I want it to be here. So x, y, that is 4, 2. So 4, 2. And then, okay, so I know I have one here. Then I have another point here, 4, 2. Then I want the third part of the triangle to be here. That is 8, 2, right? So 8, 2. And I have my axis now. Oh, see, so it's a vector, and I'm supposed to create it as a vector. So here, vector, then axis 2. So these are my points. So I want to plot this triangle. So here. So I know my points. And if I wanted to color this, I could put color equal to, let me use this lavender color. Something like that. So here. Are you clear?
Yeah, yes,
Hello?
ma'am, I'm clear. Well, yeah, I'm clear. But for that, your first polygon you drew, it has 7 points and 6 sides. Is there something wrong?
It has what? What did you say?
It has 7 points, but it has 6 sides.
No, it has 6 points. Okay, let's do it again.
No. I mean, no. This not that one. The one you. The axis one. The axis.
The axis one.
Yeah, the
Oh,
one
this
on the.
one.
Yes.
Oh, this. Okay, okay, okay. I understand what you're saying. Okay, so let me just check it. So why do I have 7 sides? Truly, truly, truly. Why do I actually have 7 sides? Let me see. 1, 2, 3, 4, 5, 6. Okay. So let's look at it. 2, 2 is here. Then 5, 2 is here. 6, 5 is here. 6, 7 is here. 1, who is that? Oh, 1, 7. Let me mute the person. Okay. 1, 7 is here. Then 1, 5 is here. And then I have 2, 2 again. Oh, so 2, 2, I came back to the previous point. So if I take this out, let's see what will happen. I like saying things myself. So let me clear this so that I have an empty place. And then let me run this. So it's still the same thing. It's the same 2, 2 points. So it will just bring it back to this particular place again. Is it clear now?
It is. It is. Thank you very much.
Okay, you're welcome. Okay, so that's about plotting polygons, knowing your axis and not knowing your axis. Just wanting to plot at any point you want. Then let's quickly do this. I don't know why this thing is not showing below, but sometimes this VMware could be just very funny sometimes. 10:59. Okay. Oh, my battery is running low. Sorry, I'm coming. Okay, so it's charging now. Okay, so let me quickly show us how to plot linear equations. So if you have a sequence of values, so I'm on page 168. I'm showing plotting mathematical functions. So you want to plot a linear equation. So if let's assign it to this. Let's just do what's in the manual. I remember I told you taught you SEQ function. SEQ is finding you want to get a range of values and skipped by skipped by a particular value. So I want to get this range of value. So I want to get I want a range of values from -2 to 2. Okay, so I want a range of values from -2 to 2. I want it to skip by 0.01. I remember I explained SEQ to us, or let me just show you for those that want to recollect. So for the purpose of recollecting, you are taking values from -2 to +2, and you're skipping by 0.01, as you can see. So this is it. So this is what first looks like. And then I now want to plot this function with first. So I want second, which is an object, my object name. I want second to be first. Whatever is in my first, I want it to multiply it by 3. I want it to multiply whatever is in my first by 3, and minus 3 multiplied by first. So I want it to do this for me as a function. So this is my first. These are all the values in my first, and this is what my second is going to look like. So I want it to do this. R uses BODMAS, so you don't need to put anything into brackets. But okay, for the sake of clarity, let's do it this way. Not necessarily. R uses BODMAS, so it's going to multiply the values first before subtracting it. So let's not confuse ourselves. So this is second, okay? Let me show you what second looks like. So these are the values in second. Oh, we might actually need to put a bracket. So I think it's doing, so let's do this.
The bracket, you get 0.
It's still, okay, it's still be 0. Oh, first times 3 minus 3 times first. It's the same thing, so it's 0. Oh, it's actually 0. Okay. Yeah. I didn't even look at that well. So it's still going to be 0. Okay.
So you can
Oh,
include
so in your it's raised to power in your manual. Sorry, it's raised to power in your manual, not first times, because I was wondering why it would be first times 3 minus 3 times first. That doesn't make sense. So first raised to power 3 minus 3 multiplied by first. So that is the function. And here, so you have this as your values for the second one. So we have two variables now, two values. We have first and we have second. So we want to plot first against second. So we're going to use the plot function. I'm just showing how to plot mathematical expressions. First, plot first by second, and then do type equal to. So let's just play around a little. Let's do type equal to 16. Okay. So what did he say? 16. Invalid plot type. So it's telling me my plot is, oh, sorry. I was writing PCH. So let's do type equal to, let me use PCH. I just want to play around. Just for us to remember all these things. 16. So here you have this. Do I actually need to put this in quotation? So let me see. Do I need to put this in quotation? It will work. Okay, it will still work. It will work. So PCH equal to 16. So you can see that it's plotted round line. So PCH equal to 16 gives round shapes. Okay, but this doesn't really make sense. We're supposed to use lines. So let's use type equal to L. You can still do type equal to L even with this. You can still, and then it just straightens everything into a line. So that means this will no longer be necessary. So it's plotted these values and drew them out. So this is plotting mathematical functions. Yeah, so that's about plotting mathematical functions. And then you could also plot two lines on the same chart. So you can see that on page 169. On page 169, and you can past 11 now. And I want us to quickly do some other ones, but try that out ourselves. Let's try the one on page 169 out ourselves. So the ones on page 169, let's try them out ourselves. Since we understand this concept, we'll be able to flow with the remaining charts on page 169. So let's go to something else. So plotting histograms. I think I've explained plotting histograms before, but let's just quickly do something on histograms, something more. The ones on page 169 are very, very similar to what we did here. So if you go through the ones on page 169, you'll be able to understand what they are saying based on what I've explained here. So let's quickly do histogram on page 171. So there's an inbuilt data called empty cars. So data empty cars. I want to load in this data. So I've loaded it in, and I want to see what it looks like. Look like this is what the data looks like, and then I want to plot MPG. That is this particular column. I want to plot this particular column on a histogram. So a histogram takes in just one value and then gives a frequency of the values based on a particular range. So let me come back to here. So I want to plot this. I want to create an histogram of empty cars for MPG. That's that particular column with several values. And those several values, I just want R to break those values into 12 for me. So I want it to break it into 12 bins for me. I don't want to specify any bin, but based on the range of values, just break it into 12 equal parts, 12 equal bins. So I will use a function called breaks. So I want it to break it into 12 equal bins for me. So R automatically takes your set of data. For example, now, if I had a data set of, say, 1 to 100, and I did breaks equal to 10, so that means the first bin will be 1 to 10, right? The second bin will be 11 to 20. The third bin will be 21 to 30, and so on. So that's what this breaks function does. So I want this to, I don't know the range of values for my empty cars data set. Although you can check it if you want. You can check your range of values if you want. But when you use the breaks function and breaks argument, you don't really need to check it because it just breaks it for you. So my values range from 10.4 to 33.9. So it's going to break this range of 10.4 to 33.9 into 12 equal parts. So it's going to break it into 12 equal bins. And then it's going to plot them for me on a histogram as indicated here. Then I want the color to be, let's use green. So let's plot this. So here, so I have an equal range of values, and then these are the, so for values between 10 to whatever is indicated here, I don't know what this is. From 10 to this, it shows that I have just two values here. And from, okay, so let me try to get the value here. Another thing is, how do you expand this place to be able to know what value exactly is here? That's another thing we have to, that's another thing that the R chart doesn't really give out rightly. So mid here should be like, say 12.5. So maybe this should be about 12, thereabout. So maybe between 10 to 12, between bin 10 to 12, we have two values. Between bin 12 to 14, we have one value. From, say, 14 to 16, we have 7 values. So it has broken it into 12 bins for us. So R summarizes your data based on the number of breaks you give it. So we gave it 12 breaks and it summarizes our data into 12 breaks. So if I gave this 3 breaks, or let me say 4 breaks, it will summarize my data into 4 breaks. So I have 1, 2, 3 bars. Let me see. When I did 12, how many bars did it give? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for 4 breaks, it's giving me 5. Okay. Okay, for 3 breaks, it's giving me 3. Okay, so that is something I have to look into. So for 3 breaks, it's giving me 3, 10 to 20, 20 to 30, and 30 to 40. So it's broke it down for me. For 4 breaks. $35. Okay, for 5 breaks. Let's see. The same thing. Okay, so I think there might be, let me see 6 breaks. Okay. Okay, so I think there might be some kind of breaks you can give to a particular set of data, or there are some specific values for breaks in histograms. So that's something I'll have to find out. If there are some specific values for breaking your histogram, or it is this particular data that requires some kind of breaks. Are we there? Please let me know if you are following what I'm trying to do.
Yes, I'm following.
Yes.
You can
Yes,
see
ma'am.
what is happening, right? Okay, cool. So it's either the fact that so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I think they are part of the histogram, and or it's not, I don't think it's about the data. There are some specific kind of breaks you can give to your data, or maybe depending on the kind of data you have, some kind of breaks might not work. So please, you can also check this. Okay, assignment. Let's do this. I'm always the one having to check, and sometimes I don't have answers. So good. So now, in the next class, I will ask Emmanuel to ask you guys, and if he doesn't ask you, I'm going to ask you myself when I come back, because Emmanuel is going to take you for the next class. I have a very important meeting. Sorry about that. On Wednesday morning, so I have to be there. So Emmanuel is going to take you in the next class. You're going to do a hypothesis test in the next class, and before the class, it's going to ask you what you found out about the breaks argument. Why is it that the breaks argument will take in some values, and those values will not reflect in a histogram? So I want to know that. So give me an answer on that. Either you give Emmanuel either in the next class, or you give me when I come in the following class. So that's an assignment for you. So please, let's find out that. I never actually noticed this. So let's find that out. Why is it that I always use ranges? So I classify my ranges. Say I want my histogram to break 1 to something and so on. And I remember I showed us in the last class, if you want your histogram to break into bins, you can specify it and say you want your histogram to break into this particular number of bins and so on. So for example, now if I wanted to, so let me copy this. I think I remember I taught in the last class. So let's just quickly see if we can do something like that. So let me see the range of this again. So the range of this is 10.4 33.9. So I want a range of 10, so I have to cover everything. So I want to do from 10 to 35. So specifying my range here, I would do SEQ equal to, that's my sequence of values. I want it to do from 10 to 35, and I want a skip of 5. So meaning I'll have 10 to that means I'll have how many now? To 15, to 22, to 25, 3, to 34, to 35, 5. So I'll have 5 bins. So I want 5 bins. So SEQ of this. Then, what again can I also specify? I can also specify my title. So main equal to empty cars. Let me just use empty cars. And yeah. So yeah, so here I specified that I want it to range from 10 to 35, but I want it to break by 5. So let's see what happens here. So you can see it breaks by 5, 10 to 15, 15 to 20, 20 to 35. So I use this most of the time, and it actually gives me a better view of my data. But then using breaks, I want to understand how to use breaks more. So that's an assignment for all of us. So all of you, no, not all of us, all of you. I'm not included. Okay, I'm included because I'm also going to try to find out. So tell me why some of these breaks don't work. Is it because of the data, or is it that there are some specific kind of breaks you can give to histogram data, to data you're plotting with a histogram? So tell me next week, or you tell Emmanuel, I said next week, you tell Emmanuel in the next class, or you tell me in my following class. But I'm going to tell Emmanuel to ask you in the next class. So let's try to find that out. So I hope we understand that. Any questions before I move into another thing? Any questions? If you don't have questions, just tell me I do not have any question. So I'll just move.
No question, ma'am.
I do not have any question.
Okay, thank you. Okay, so that's about histogram. All these are histograms. I'm tired of plotting histograms. We've done histograms already. So let me move to so let me move to time series graph. So time series graph, that's page 176. We can't cover everything, so there's some things you have to go back to your manual to do by yourself. So let's go to time series graph on page 176. So let's quickly, let me see the time before I keep talking and talking. I think I like talking too much. 11:17, okay. So let me come back. Yep. So let's plot time series graph, okay? So let's use an inbuilt data set. Let me see if I'm not skipping anything. I hope I'm not skipping anything. I'm sure that I'm not skipping anything. Okay. I'm not. All right. So still in your manual, page 176, time series plot. So let's load in this data. It's an inbuilt data set in R. Oh, okay. So there's something. So this data set is actually not as it is. So let me show you the data set in R. These are data sets in R, okay? And we want to use LDET, MDET, FDET, and they are from UK long det. But the funny part is, where is UK long det? So we have C, UK long det. This is FDET data. So UK long det is not particularly a data set name. So we might not be able to load this in. It's not going to work. I tried doing that. LDET, C, UK long det, and MDET, UK long det. So we can't load them in, but I think they are already loaded in. So let me show you so I was trying to load this in, I couldn't. As indicated on page 176, I couldn't load it in. So I just did this and it worked. So the purpose of this is for practice. So you don't necessarily, you know how to load in data set if you have your data set. So you don't have to dwell too much on why it is not loading in and why it is loading in and all. So UK long det. Let me show you. You see, it's not even coming up. Normally, if I was typing empty cars, see, empty cars, you see it will come up. So UK long det is not coming up, meaning that it is not, will I use the word loadable in now? So we can't load it in. So it's going to, okay, so it's actually loaded in. So let me see if it shows. Okay. Or maybe it's just doing scam for me. So see, object not found. So it's scamming me. So basically we can't load it in. But there's something I discovered. I discovered that if I do LDET, MDET, it will also not show. But if I actually make use of it, right, it would show. So let me see, how did I even do it that day? So yeah, if I actually make use of it, it will come up. So I discovered this. So we're going to just work with what I discovered. So we cannot load them in, but we can use them. And the major thing is to be able to use them, right? So we're just trying to learn something. So let's forget about the fact that it is not loading in. The fact that we can see it is enough for us. MDET. So basically this data, MDET is the number of male deaths and male death from lung disease. So UK long death. So it's a data set that comprises LDET, MDET, and FDET. So LDET is for every one of them, male and female together. MDET is for male death. Female death is for FDET is for female death. So this data has a time series period that we cannot practically see. It has a time period that we can't see, but it's going to reflect when we are plotting our data. So it's an inbuilt data set that has some things to it somewhere, but we cannot practically see it. But then these things are represented by years. So, for example, in a particular year, we had 2,134 deaths, and so on. in a particular year we have 1,863 deaths, males. So just take this as understanding how to plot different values on different levels, factor levels on a particular plot. So we are going to plot 3 line graphs on the same plot. So and there's also the F deaths, which is of course is for the female deaths. F deaths, number of female deaths that we had. Yep. So here. So that's. So let me just remove this. I have too many things already. Okay. So let's plot this. So let's plot. We're plotting. We're plotting a time series plot. So ts.plot for plotting time series. I remember I told you last week. So we're plotting L deaths. That is the death of all of them joined together, combined together. We're plotting M deaths. See, now it's coming up. Can you imagine? So we're plotting F deaths. So we're plotting the 3 of them. X, all of them are values that we reflect on the graph. So we have the L deaths, we have the M deaths, and we have the F deaths. And something, we're also going to add legends. We're also going to add legends to just show these different values. I remember I explained how to add legends in the last class. So please give me a minute. Okay. So this then, okay, from your manual 176, I think I mentioned that already. So we'll label the x-axis as year because it's going to reflect years. Although we cannot see the years, but it's an inbuilt data set that already shows time series. So the years will reflect. And then y lab will be deaths. That's the number of the volume of deaths. And then we are going to specify line types. So I remember I told you about line types. We have line type 1, 2, 3, 4, 5, 6. So let me see where I put it down. Line type 1 is, I think I wrote it somewhere so that I will tell you. Or have I told you already different line types we have and the numbers? Please let me know if I've told you, so I'll stop looking for it.
No.
Okay.
One that you said dotted.
Yeah.
Yeah,
Okay.
I think you told us.
Okay, so I said line type 1 solid, 2 is dashed, 3 is dotted, 4 is dot dash, 5 is long dash, 6 is 2 dash. So we have different line types. So I want to specify line types for this. So I just want to specify line types 1, 2, and 3. So I can just put it as a vector since I already know what I want to specify. So I'll just put line type C of 1 to 3, meaning that line type 1 should go for L depth, line type 2 should go for M depth, line type 3 should go for F depth. So I can put it as a vector too. So that would also work instead of specifying line type for each of them. So
if you were to specify for each of them, what command would it be? Would it be LTY equals LDET in brackets 1 or something?
okay. So so let me see if I want to specify for each of them. So LTY1, also, how will I be able to specify for each of them? So I've not actually tried that, but then we can try it. But before that, let's do this one first. I've not actually tried specifying line types for them individually, but there should be a way to do that. Okay, let's just do for this first. Let's just do for this first. As indicated in your manual. While I think about it. Then what else? Okay, that's all in the manual. Why? Yeah. Okay. Oh, I'm supposed to have added something, right? Okay, okay.
I think it just goes accordingly. So if you use a comma to specify the first, second, and third, that should work.
That should
Just
work, right? Else y equals 1, else y equals 2. Okay. Let's do this first. Let's do this first. Let's do this first. I want us to do this first before we come to that. Why is this not running? First of all, that's my own issue. So let's do this first. So let me explain this. Then we'll try the comma. So specifying it one after the other. Okay. So if you look at this, oh, I'm sorry. I need to plug in. Okay. Please give me a minute. Okay, sorry, I needed to quickly answer a message. Okay, so if you look at this, you see that this is for L debts, this is for everything together. The next one is for M debts, and the last one is for F debts. Okay, so she said she tried to do one after the other. So let me see. Let's try to do one
Hello?
after the other. You're not on mute. The person talking, just so you know. Before we hear all your conversation, everything. Well, I would have just kept quiet so that we'll just hear what you're saying. Okay. Then okay. So it doesn't work.
in the vector format. Vector format.
The vector format.
Yeah.
You know what I'm actually thinking? No, tell me what you're saying because I'm thinking of doing something. But tell me your own first. Tell me your own. I'm listening. Come again. Huh?
Change the line type. Change the line type. You can just be also equals to the open bracket 3, comma 4,
Okay, the
comma.
vector. Okay. So now that's exactly what was on my mind. So one C of 1, maybe 1, 3, 4, or 1, 3, 5 or something. So instead of doing something to something, so it changes it. So it's like specifying vectors. Instead of doing a range, you just do the normal 1, 2, 3 and all. And then I could also include colors. If I wanted to include color, I could do a form of vector too. Let me go to the next line. So color equal to red, blue, blue, and green. Okay. 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 So this specifies colors for me too. So I can choose colors for each of my lines. So basically, it's just specifying in vector-like format according to the order that you input your values here, whether LTY or whatever. And there's also something called line width, LWD. I think I told us about LWD. you could specify your line width. So you could say 2, 1, 1. So you want the first one to be a bit thicker than the rest of them. You have the first one being very thick. So another thing you can do is add legend. So let's add legend to this. Let's add legend to this. So legend let's select a position. So you can use locator to select a position, okay? And we only want one position. We're not doing 6 positions. We just want a position for our legend. So we're going to select the position ourselves. Then we want the legend to carry L depths for the first one, right? Then we want it to also have M depths for the next one, M depths for the next one, and F depths for the following one. Then we want to specify the PCH. So the PCH, we want to specify the PCH of each of them, of L depth, M depth, and F depth in the way it follows, okay? So we want the first PCH to be, so the first one is dotted, right? So what PCH can we use to represent that? We have different shapes. So let's use for the first one, let's use something that looks like lines. Let me check our PCH values again. I have to go to slides. So let's check our PCH values. I want to see what looks something like lines and all that we can make use of. So let's see. 151 looks like lines, 150 rather. Then we also have dashed lines. So what can we use to represent dashed lines? So sometimes some of these things I prefer to use colors, because if we wanted to use the lines as the legend, we might not be able to get it accurately. Although there might be a way to include lines as legends, but for the purpose of this class, we would probably just be using colors, because we cannot get the ones that represent dashed for us, and huge dashes and short dashes and so on. So maybe we should just make use of colors, or maybe we should make use of shapes, whichever way. So let's do what can we use now? Maybe we should just use colors then. So let's do PCH let's do the same PCH 15. Let's use PCH equals to 15 for everything. But then let's specify the colors. So colors equal to C of, I'm just trying out stuff. Okay, so let's use colors equal to C of red for the first one, right? Red for L depth, okay? Then blue is for the next one, and then green is for the last one. So green for the last one. So let me reduce this, please, so I'll see what I typed properly. Okay. So PCH equals 15 is like a square. So let me see. Let's run this. So it's telling us to choose our location. Like you can see, what location do you want this? So I want my legend to be here. So here you have it. Yep. So this is my legend. I usually use colors, okay? But I'm just trying to see, what if we wanted our legend to actually be we want straight line. Then we want, maybe if we're not using colors, we're just using lines, and we wanted one to be straight line, another one to be dashed line, and another one to be broken lines or something, or different kinds of lines. I think there's a way to do that. Maybe LTY. I'm not sure. So let's just okay. Let me try it. I'm just trying stuff. Oh, as I said, to learn, you just try stuff. So let's do LTY. If that doesn't work, then we just stick to our colors. So LTY, let's do LTY. Line type, first line type. We have line type solid, right? So line type solid is 1. Another line type solid line type that we have is 3 and 5. So 1, 3, and 5. Okay. See it better. And let me expand this back. So let's do this. Okay. Oh, before that, let me let me move.
I can no longer see your screen now.
Oh, you can't see my screen. I'm coming.
Yes.
I will reshare my screen. I will share my screen. I'm coming. Just give me a minute. I will share my screen now. So, okay, you can see it now. I should continue. You can see it. Okay.
Yes.
Okay, there's no problem. Okay, so you saw this, right? Do we all understand this one? Do you all understand what I did here? Do you have any questions as regards what I did for this first part? Any
I don't
questions as
understand
regards this?
locator one.
You don't understand what?
Locator one.
Locator 1. Do you know what the locator argument is used for? Do you remember me using locator at any point in time in this class?
For the polygon, yeah.
What did you say?
For the polygon, yeah.
You remember, right? If you remember me using locator, I used it for a polygon, right? And I did locator into 6. And then I was able to specify 6 points, right? So now I'm using locator into 1. I only want to specify 1 point. And the point I'm specifying is the location of my legend. Okay, so let me remove all of this and do it again. So this is TS plot, okay? So I plotted my graph. Oh, I have it, comma. So this is my graph, right? And then I want to create a legend, but I want to choose the location by myself on my chart. So I specified, you understand PCH equals 15, right? I want to use squares as my diagram to represent my legend. And then I specify the colors. So if I run this, it will tell me that you can select your location. Look at here. You see that there is no prompt to enter any code, meaning that you should come here and select a location. So see, I'm going to select this location for my legend. So you just click and it puts your legend there. Do you understand now?
What if you don't use the locator function?
You specified, then you have to specify where you want it to be. So let me rerun my plot. So I want to specify my location using X, Y. Okay. So I'm going to do location X.
Like automatic positions for legend?
That's what I'm saying. I want to specify the location for the legend. Is that not what you're asking?
Without specifying.
Without specifying. No, you have to specify a location now. You are plotting a graph. Won't you specify where you want your legend to be? In your Excel graph. Huh?
I was just asking if there could
No,
be
no,
like an
no. If it's what?
if
Come
there was
again.
if there could be an automatic selector.
No, 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 no. You have to specify where you want your legend to be. Yeah, you are creating a legend, so you specify where you want your legend to be. So I could say I want it specified at let me see, where can I put now? I don't know if this will work, but I've not tried it before. I always use locator. So let me try something. Location on the graph.
I can't see your screen. I mean, I can't see your screen.
Are you the only one that can't see it? Is there any other person?
I can see it.
Okay.
Can you see it now?
Yes, ma'am.
No, I can't yet.
You can't yet. Did you just black out or what happened?
I don't know. It's just showing everybody's names instead. Is there a way to change the view or something, please? Anyone?
It's showing everybody's names. What do you mean?
Comment.
Okay.
Daniel, check the last end of the sorry, the lower right of your screen. You should be able to click on the
Yeah, is Henry's name that I just showing when I click the lower hand.
yes. So it will soon. I guess it will soon load. I had the same thing here some minutes ago. Sha.
Oh, okay. Thank you.
So it doesn't work. So let me do. Okay. So
Oh, you didn't specify one.
I'm trying to specify it without using the locator function. So specifying it without using the locator function um not working at the moment. So, or let me see. Okay. So for this you will have to use locator function. We can find out another thing we can find out coming to the next class is how to do it without using locator function. The locator function is what I majorly use for specifying my location of my legend, because sometimes I have my graph this way and I want the legend to be here or at this side and all. So, okay, hold on. Okay, so we have to find out this, but for now just know that you can specify your location with your locator function, okay, with your locator argument for the purpose of this class. Then maybe we can also check that too. Specify my location now. Okay, so this is giving me headache now. Okay, let me plot it again. And then specify my location. Okay, something is wrong. Okay, so it has specified. So for the purpose of this class, let's use this. But then, oh, where's my pen? So some things we have to check, these breaks and specifying locator function without using locators, right? So there are two things we have to check now. And I will ask you in the next class. So come up with give me ideas on what you've learned or what you've researched on. So how to use breaks, why does it not work for some particular functions, and then the locator function. Can I use using values instead of the locator argument? So for the purpose of this class, we'll do this, but then we're going to check this. So I was also trying to using line types for legend. Okay, I was trying to see if I can use line types for legend instead of using this. So if I had my plot as, let me copy, I'll come here. So if I had my plot as just these lines without colors, maybe I had just lines without colors, and I wanted to use line as my, just the lines as my legend. Okay, let me take off this one. Escape. So I have this, and I wanted to use just lines. So let's see what happens. So just line types. Okay. line types 135, and then here. Cool. So here you have it. We want just line type, so that is what it gives us. And then, so I specify the line types for each of them. And now if I want this to be as thick as this, I'll put the line width too. So the line width is C of, the line width we used was 2,1,1.
I'm sorry to interrupt, ma'am. My name is in
Yes?
the lobby.
You? Oh, someone
Okay,
is in the lobby.
just hold. Thank you, ma'am.
Okay. Daniel, can you see my screen now?
Thank you.
Can you
Yes,
see
I
my
can
screen
now.
now?
Yes, I can now. Thank you.
Okay. So using line types for the legend, here it is. And then using specifying the line width, it would show the L depth line to be thicker. Did it change it? I'm not even sure if it changed it. But I think it did. It's just better to zoom these things sometimes. Oh, okay. So I know what happened. So let me do this again. Escape. It's still expecting me to put a locator. Then do this and then specify my location. So you see this is thicker than before. So you could also add a title if you want, and that, and so on. You could add a title to your legend using the main function. So that's about time series plots. Let's quickly create a pie chart. Have we created a pie chart? Hello? Have we created a pie chart? We
No,
haven't.
we haven't.
Oh, okay. Okay, so let's quickly create a pie chart. So let's use this data. Data on page 177. Oh my god, I know time is gone. 11:49. Okay. So let's use the data on page 177. So let's create this data set, vector 10, 12, 4, 16, 8. 10, 12, 4, 16, 8. Okay. I didn't want this. Then let's create its labels to be US, UK, Australia, Germany, I like putting my quotations first. I don't like putting it before now. It's very annoying. And then France. Okay. So all right, so we have slices and we have labels. So now we want to create the percentage because it's the percent. We want to plot the we're going to plot the slices by labels, okay? But then we want to include the percentage in the in the chart. So before doing that, let me plot the pie chart. So you'll be able to see the difference in what I've done. So I'm plotting slices, then my labels, that's the labels for each of them. So you can use the labels function to just label your pie chart. So to not confuse us, okay, let me just put this as LBLS. So these are my labels. So my labels will now be equal to LBLS to label my pie chart. Then I want my color to be, so they say, okay, in the manual they use color rainbow, right? So let's use color rainbow like they used, and we can then try doing another things later. They use color rainbow, and they said for the length of LBLS. So let's do that. Length of LBLS. and then name. That's the title. Okay, type out of countries. So here, so let me do something. Okay, this is what we always do, right? Color equals rainbow. Let me take this out. Okay, so you have to specify where you're including your color in your pie chart. So length, we have to put the length of LBLS, and the length of LBLS is, what's the length of LBLS? The length of LBLS is 5. 1, 2, 3, 4, 5. So for five of them, specify the rainbow color. So here, so let me see, what if I did not want the rainbow color? Okay, before that, let me show us something. So this is the length of LBLS, right? 5. So I'm saying rainbow color for the 5 of them. So now let me do blue of length of LBLS. Okay. So it's not working. Okay, this is color. Could not find function blue. Okay. So rainbow is a function. Okay. But then I want to see, what if we wanted different colors for different labels? That's something that we'll have to find out. So what if we wanted different colors for different labels? Say maybe blue for which one? Okay, but do you understand this first before I start running around? Do you understand this? The rainbow is a function and it works for all of them, because I said I wanted to work for the 5 of them. So that's the function. So tell me, you want to tell me something?
I think the
Yes?
rainbow, I think, just like the normal thing, rainbow is like trying to take different colors. I think we can actually specify kind of color that we want.
So this is a function, okay? And then if I want to specify different colors now, for example, maybe blue, red, green.
What's going on too?
Green, orange, and lavender. Let me cut this. So if I wanted to specify my colors for the 5 of them, so you see, it specifies the colors for each of them according to the way they are labeled. So for US, we have blue. For UK, we have red. For Australia, so rainbow is a function, okay? So rainbow just helps you put different colors for different, for each of them, for all of them. And you could also do, I want to bring back my rainbow function. That's why I'm coming back here. So rainbow for length of this LBS. Okay. So you could specify each of the colors you want, or use the rainbow function to give colors to each of to give whatever colors it wants to give to each of the different sectors of the pie chart. So if I wanted to add a percentage value to this, I have to calculate the percentages and paste it. So let's calculate the percentages. So this is too long. Let's use what is this manner. So percentage. So I want to get percentage of Round. Don't worry. After everything, you can ask your questions. I know you might have questions. So I want to round this up. I'm going to round it up to the nearest whole number. So I want to round this up to the nearest whole number. So I'm just going to use round. Then I want to get percentages of each of them. So it's going to be slices. So for example, 10 divided by the sum of everything times 100. 12 divided by the sum of everything times 100. 4 divided by the sum of everything times 100, and so on. So those are the percentages. So it will be slices. That's each of the slices over the sum of each of the slices. Okay, then multiplied by 100. So this will give me the percentages of each of them. So if I say what is PCT, you see it will give me percentages of each of them. So it gives me the percentages of each of them. So 20%, 24%, 8%, 34, 32, and 16% for each of the slices. So I want the labels. I don't want the labels to just be like that. Okay, I want the labels to carry the percentage. So I'm going to use LBLS2 as my new label. And then I'm going to use a function called paste. And I remember I've taught you how to use paste. You are joining something, you are joining an object with another object, and you are putting a separation value. So we don't have to put separation value if not necessary. And if you want to, you can put it. So let's join LBLS, which is all of what is here. That is UK, US, France, each of them. So let's join this with the percentage value, which is each of this one. So let's join this with PCT. So that means UK will be, or let's start with US. So that means US with 20. So we want US 20. We want it to be like that. Then let's add okay. So let's do it like this. So first of all, let's paste this with PCT. Okay, so this with 20. Or before this, let's come back. Let me come back. Sorry for confusing you. Let me come back now. So I have slices, I have labels. Forget about all I've said. I'm coming back now. I have slices, I have labels. I calculated the percentage value and I rounded it to the whole to the nearest whole number. Slices divided by the sum of slices multiplied by 100, which is the way to calculate percentage. I don't think I need to explain that further. So that's the way to calculate percentage. So I check my percentage values and I add this. But I don't like the way they look. I want them to have percentage sign in front of them, okay? So I'm going to create a new value called PCT2 that would carry these percentages with the percentage symbol. So I'm going to use the paste function and I'm going to paste each of the percentages and include this percentage sign. So I'm going to paste each of them with the percentage sign and I'm going to separate them with nothing. So I don't want them separated by anything. Okay, so this is what I'm going to do. So now let me see what PCT2 looks like. So what does PCT2 look like? So see, it now has each of them as this percent, this percent, this percent, this percent, this percent. So I've done that to PCT2. Now I want my new labels to carry whatever the labels are and PCT2. So I'm going to join my labels with PCT2, okay? And then I'm going to separate it by a comma. So I want to separate it by a comma, then a space after the comma. Or let me put, yes, a space after the comma. So this will be my new labels. So let me see what my new labels look like. So you see, US 20%, UK 24%, Australia 8%, and so on. So now in my new pie chart, I want this to have the new labels. So I don't want the old labels anymore. I want the new labels. So I'm going to create a new pie chart that carries LBLS2. And here you have it with the rainbow colors. So this, sorry, there's something. LBLS, LBS, LBLS2. LBS object not found. Okay, I know what is happening. LBLS2. So length of LBLS2. So here, so you see. So tell me if you have a question. Let me know. If you have any question, tell me. Somebody's trying to come in, right? But so questions. Tell me if you have any questions, and tell me where you have the question. Don't just tell me I don't understand everything. Do you have any questions? If you don't have any questions, just tell me I understand. I don't have a question. Anybody, 2 people, and then I'll move on.
I don't have any question.
Wow, I'm happy. I'm very, very happy. You guys don't have a question. Wow. Wow, that's awesome. That shows that everybody was following. Thank you very much. Clap for yourself inside your house. Don't clap into my ear because my ear would blast if everybody starts clapping. But clap for yourself inside your houses. Wow, I was expecting questions. Thank you very much for following. So that means you followed because I actually took it one after the other, and I'm glad you guys followed. Thank you for following. So that is about creating pie charts, and it's past 12 already. So we're going to do just one last thing before we go, and then you can definitely go into your 2 last things, okay? And then please go into your lab manual and work on the remaining visuals that will probably not worked on, okay, to help you to understand this more. So plot with multiple variables, we've not covered it at all. So you're going to give me some minutes of your time to quickly cover plot with multiple variables. And then plot with multiple variables uses the pair function, the coplot function, and bubble plots. So I'm going to show us the pairs function and the bubble plot, and then you can go and check the rest of them yourself, and then we'll be done with plotting graphs. Yes, so let's do the plot function. So let's get this data set called ozone.txt. Let's come here. Ozone. This is ozone.txt. Okay, cool. So ozone.txt. So we have ozone.txt. So let's load it in. Ozone data. Read.table. Then reading data sets. Reading from data sets slash. So it's ozone.txt. Okay. And then header equals true. Header equals true. Okay, so ozone, let's view it. Let's view ozone data. Let's see what it looks like. Ozone data. So we have RAD, TAMP, wind, and ozone. So they are all values. So we want to see the relationship between all of them. So you use the the pairs function to pair all of them with one another. So let's come back to here. Okay, and then let's use the pairs function to plot all of them. So pairs, so you're just taking the old data set. Since you are pairing, you are plotting everything. So let's just plot ozone data, comma. Then you need to use this panel equals panel.smooth because it actually helps you to put lines to your data. But let's do this first. Okay, so it gives us this, right? It has plotted all of them. Let me cancel all of these plenty things I have here. There are too many. It's too many. I have too many things here. And I want to see the ozone data. No. So ozone data. So here, this is ozone data. Okay, RAD, TMP, wind, ozone. So it's plotted everything against everything. That is basically the meaning of this plot. So it's plotted rad against temperature, rad against wind, rad against ozone. Temperature against rad, temperature against wind, temperature against ozone. Wind against this. Ozone against this. So that is what it did. It's plotted everything against everything. Now, I want a line, okay? I want a line. I want you to show me a correlation line. So you're going to use the panel equals panel.smooth. So it shows you the smooth part of your data. The smooth part of your data, it shows a relationship. So see, it helps you to show this smooth the relationship in your data. So it shows the correlation. So let me quickly explain this. Can you hear me?
Yes, we can.
Okay. So it explains the relationship in your data. So now note that wherever okay, for example, if I I think I remember I explained something like this at the beginning of this graph class, but then let me just do it. Let me just explain it again. If you have this, okay, go to your left and to your right. Whatever what will I call it now? Whatever values or whatever variables you have towards your left and your right are what gave you the plot. For example, I select this plot, I go to my left. So now I don't have to go to the extreme end. I've seen it already, TMP. So it means TMP temperature was plotted against RAD. That's just what it means. If I come to this, if I go to my right, wind was plotted against what? RAD. That's just the meaning. If I come here, go up, TMP was plotted against ozone for this one. If I come here, RAD was plotted against ozone. That's what I have here. So that's just the meaning. Just go to your left or to your right, to your down or to up, and you see what it was plotted against. For this one, TMP was plotted against wind. For this one, TMP was plotted against ozone. So we can see that there is a correlation between, let me see which one has a good correlation. Between wind and ozone. So see wind and ozone. So this for wind, for the plotting, we're plotting wind against ozone, right? So just go to the extreme end to see the values for ozone. So we're plotting wind against ozone. So if you go to the extreme end, you can see 0, 50, 100, 150. So meaning this is 0, 50, 100, 150. Therefore, wind, go to the extreme end, you can see 5, 10, 15, 20. So if we wanted to check this, we would see that when ozone was about 100, looking at here, when ozone was about 100, wind was really low, okay? When ozone reduced to say 50, looking at here, when ozone reduced to about 50, wind increased to about 6. When ozone came to say 20, looking at here, wind came to about 11, meaning that there is a negative correlation between wind and ozone. So as ozone is reducing, wind is increasing. That's why we have the graph go this way. So graphs that go this way shows positive correlation. Graphs that go this way show negative correlation. So this is the way to check correlation between your data sets. So you see for this one, there's not much correlation. It's like, it's not going up and it's not coming down, it's just like there. So between rad and wind, we don't have a significant correlation between rad and wind. Look at the way the graph is. It's not going up and not going down. This one, rad and temperature, went up, then came down. So maybe there was like a positive correlation between them, then negative correlation. So that's the way to check relationship between different variables at the same time. So that's what this chart shows us. Any questions? Any questions, please? Any questions?
No, I don't really understand the correlation, but please, I'd like you to use wind and ozone to explain. Or
Okay.
ozone and wind.
Which part don't you understand? Is it that you don't know which axis they connect to, or you don't know the meaning of correlation?
But the one beside the wind, which axis
Ah,
is correlation?
which
But the
axis?
graph beside the
Graph.
wind, the one beside wind.
The one beside wind. This one.
Yes, that one, yes.
Okay, you don't know what? Why don't you know?
What's the correlation between ozone and wind for that one?
Okay, so for this graph, we're plotting ozone against wind too, right? Okay, but then it's in a different way because ozone now is on the y-axis, okay, and or let me say okay, this is y, this is x, okay, this is y, this is x. So now ozone is on the x-axis here. Here, ozone was on the y-axis. Okay, and wind was on the x-axis. Look at, wind is facing the x-axis, ozone is facing the y-axis. But here, ozone is on the x-axis because you know your graph is like this now. X-axis down, y-axis up. So for this one, this is y, this is x. So now ozone is on the x-axis, wind is on the y-axis. So Let's look at ozone. So let's look at the graph 0, 50, 100, 150. So this is like 0, 50, 100, 150. And the wind is like 5, looking at here, 10, 15, 20. So here now, when ozone was about 0, wind was about 12. Okay? When ozone was about what am I saying? Yeah, 0, wind was about 12. When ozone was about, say, 50, wind was like 10. So let's see this point. When ozone was about 100, wind became 2. So you see that there is a it's as ozone is reducing, wind is also reducing, so it's coming down. Okay, so there is a positive correlation between them. Same thing with this one. So it's also the same thing with this one. So there's a positive correlation between them. So as it's increasing, this one is increasing. As this one is increasing, this one is increasing. Or as it's reducing, sorry, I mean negative correlation. As this is reducing, this is reducing. As this is reducing, this is reducing. So they're reducing together. So there's a negative correlation between them. So assuming as wind was increasing, ozone was increasing. So if they were going up, up, up this way, that means to be a positive correlation. But this is reducing and this is reducing, so it's a negative correlation. So maybe it was the English I used that made you confused. So if X is increasing and Y is increasing at the same time, you have a negative correlation. If decreasing rather, if Y is increasing and X is increasing, you have a positive correlation. So that's what I meant to say. Do you understand now? Do you understand?
Yes, ma. Yes, ma.
Okay, okay. So that's about that. Then oh, there are some special plots here, but we might not be able to read them. Let's just do bubble plots. There's one special plot here which should have been good to read, to do. Okay, let's do bubble plots because of time. So let's quickly do bubble plot. So bubble plot takes in 3 variables. Okay, and then bubble plot is like this. It plots x comma y. Then the bubble now shows how big each plot is. That is the volume attached to each point. So let's do it with this data set. Pragmatic acid. Oh, it's a lot. We might not finish it today. Okay. It's a lot. So we might have to try this one on our own because it's actually a lot. It's actually a lot, especially, let me see. What are the following commands?
Can you just explain the concept behind bubble chart?
Yeah. So bubble chart is, let me see if we have it in the slide. Let me see if we have it in the slide. Oh, I'm opening something else. Oh my god. I'll explain the concept behind bubble charts. It's in this slide. Okay, it's not in the slide. This last slide. Everything I explained is basically in the slide. Like all that is in the slide is I've explained already. So am I opening for you? I'm opening the wrong thing. Graphical analysis in R. Then here. Okay. So this is bubble plots, okay? This is an example of a bubble plot. So in a bubble plot, I don't know, I feel like please give me a minute to okay. So, well, the concept behind bubble plots, I would have loved to do this, but man, it's long. We might not live here today. So it's actually very long. So this is what bubble plot is. You are plotting x by y, okay? Say you're plotting pH by this value, a by pH, okay, x by y. But then for example, this is a point, okay, and this is 3.5 plotted by 4.7 or so. So he plotted this by this. But then there's going to be a third value. So say your third value is maybe let's say volume. Let's say your third value is volume. So depending on the volume, whatever volume this point gives you is how is going to be how big your bubble is going to be. So if that means this point to this point would have just given us a dot, right? But then say the volume was 3. That's why we have the bubble as big as this. Now let's look at this one. We have x value maybe 3.7 and y value 5.2, okay? But we have a bigger bubble. We have a bigger bubble because the volume here is probably like 7. So the bigger the bubble, the bigger the third variable. So this is variable 1, this is variable 2, then there's a variable 3 that acts on each of the points. And this variable 3 tells you how big your frequency or your volume or whatever it is in your column is. So this now shows that variable 3 is actually very huge. So variable 3 is probably like maybe 50 compared to this that's probably like 3. So your bubble shows how huge your third variable is. So that's what the bubble chart does. So here they created a function to create bubble chart for us, but it's a very long function. Maybe we can take our time some other day to do it together. But then that is basically what bubble chart does. It plots your bubble according to how large your third variable is. So it takes in x, y, and z values. This is x value, this is y value, and your z value is reflected on each of the points. So that's what a bubble plot does. Do you understand my explanation?
Yes.
Okay. So that's what the bubble plot does. We can do this maybe some other time. Do this bubble plot thing. It's very long, but they were basically just trying to create a function that will create the bubbles for us. And we won't be able to do that today because of time. So 12:19. Okay, 12:19. Okay. All right, I think that's basically all. There are some special plots. I don't know if I should quickly touch one special plot or let's just release us and go because we spent so much time already. This 12:19. We were late last week and we are turning late again this week. So what do you guys think? Should we do one of these special plots or we should just call it a day and you go and try it on your own?
Let's call it a day to help
Okay,
us to
cool.
practice.
Okay.
Right.
So that will be all. And do you have any questions from all the plenty jargons I've said today? Any questions? Any questions? Don't forget your assignments. Do not, I repeat, do not forget your assignments. Tell me why the brakes are not working. And also tell me if I can use values to set my legend instead of using the locator argument. So, yeah,
Please, I have a question, ma.
okay.
Yes, the very first data set to worked on, that experiment data, you were trying to say something about using box plot and bar plots. I didn't really get what you were saying. You were saying one was for categorical data, but I noticed that the data set there is nothing categorical about it. So I didn't really get the differentiation you're trying to point out today.
There's nothing categorical about which data set.
The very first one, experiment data, I think.
Experiment data. Let me see experiment data. Experiment data, okay. You said there's nothing categorical about it. Why do you think there's nothing categorical about it?
Okay, I felt so. I'm just saying numbers. I thought categorical data. So I felt this is numeric. I don't know.
Okay.
Oh,
So
okay.
you're mixing it. This is x-axis. You know, it's the x-axis that carries the categorical variable or continuous variable, right? So we used exp for our x-axis, and using exp, it was a categorical variable. If it was a continuous variable, it would have probably given you a line chart. But because we have just 5 variables, it has shown that it's categorical. It is not continuous in any way. So assuming we put output on the x-axis, probably it could have been continuous because we have so many different kinds of values here. So sometimes too, numbers can be categorical, e.g. months 1 to 12. So if I have months 1 to 12 and I represent them as 1, 2, 3 up to 12 instead of January, February, March up to December, it is still a categorical variable because you cannot have more than 12 months, no matter how hard you try to have them. So that could also be a categorical variable, but then it is a categorical variable represented in form of numbers. And in that kind of situation, you have to indicate it. So that is another example. But based on the fact that we used x as this variable as our x-axis, it is a categorical variable. And it's plotted, obviously, it's plotted a box plot for us because it's categorical. So see. So there. Any other questions? Any other questions? Okay. So no
Hello, ma.
questions, right? Okay, yes.
Okay, I would just like to say that you should please kindly send the script
Okay.
to us,
Has Emmanuel sent anyone
like
to
you've
you?
been doing.
We didn't get
Yes, he
that on the
sent
last
the
class.
previous one,
Oh, he sent the
but not
previous
for the
one,
last class.
but not for the
We didn't
last
Yeah,
class.
get it
but
on
not
Okay.
for
the
the
last.
last class.
Okay. Which one was the last one I sent? Let me see. Let's see. Which one was the last one I sent? I want to know.
3rd of August, I think.
3rd of August. And I sent this and this, right? So I'm going to send 5th of August, 7th of August, and 10th of August, right? Okay. Okay. So I'll
Yes.
send 5th, 7th, and 10th of August. So yep, I think that's all. So no questions again, right? So no questions. All right. So in the absence of questions, let's call it a day. Thank you, everyone. I wasted your time again as usual. Thank you for waiting behind. Hope you learned something. How was the class?
Learned a
Comments.
lot.
Okay. No other person is saying anything. It's only Adetoro that's been talking since.
That was fine.
Yeah, I learned a lot, so thank you very much.
Okay.
My head is
Yeah.
full because
Okay.
naturally I don't know, I do not like plots naturally. I don't know
Oh,
why.
naturally. And you want to be a data scientist?
I know, right? I'm fighting hard to learn it very well, so
Fight,
I enjoyed
fight,
this
fight.
class. Thank you very much.
Okay, you have to fight, please. As a data scientist, you need to love plots, and you are going to be doing serious, difficult, no word plots and all. These ones are still very simple. So, yeah. Thank you, everyone. Enjoy the rest of your day. Thank you. Bye.
Thank you.
Bye.
Bye.
Thank you.
Bye.
All right. Thank you.